data structure. So what is meant by a data structure? So data structure is nothing but simply it is a collection of data values and the relationships among those data values and the operation that we have to perform on those data values. So simply the data structure is nothing but it is a collection of organizational data. Organizational data means we have to give some relationship between the one data element to another data element, one data value to another data value. So that's why that is called as a relationship here. And the operations on those data values. So operations, what kind of operations you have to perform on those data values. So those things are nothing but a data structure. And usually if I want to work with the data structure, so majorly we need to consider about the two aspects. So what are the two aspects I need to consider means here? The one aspect is regarding to storage. That means how I am storing my data values. And the second thing is we need to consider about the how or what kind of operations that we have to perform on those particular data values here. So these are the two major logical concepts we need to consider. So while you want to work with the data structures here, okay. So what are the different types of data structures? So we are having means here, we may be categorizing your data structures into these following types. That is a simple data structure and another one is a compound data structure. So in the simple data structure means here, just we can define a simple data structure as the data structure which takes less than one value, that is a single value. So if it is take the single value, so then that type of data structures are called as a simple data structure. And the best example for simple data structures is simply you can take the your primary data types and arrays, pointer, structures, whenever they are taking the only one value at a time. If it is takes more than one value, then these are not considered as a simple data structure. Simply these are considered as a simple data structure because of it takes only one value at a time here. And the second thing is compound data structures. So compound data structure means here if it is take more than two values, more than one value, more than value means maybe you are taking the two values, three values, four values, like that. If it takes the more than two values, then it is said to be the compound data structure. So usually the compound data structure means here nothing but the best example for your compound data structures are nothing but so stack, queue, linked list. So these are the compound data structures we are having. So that compound data structures are nothing but it takes a more than one value here. So in the based on the way of we are performing the operations, either your operations you have to perform in sequential order or either you need to perform your operations randomly here. So sequentially means so if I want to perform what kind of operations usually on your data structures, the major operations are insertion, deletion and display. These are the major operations you have to perform with your data structures here. So insertion means we need to place some value into your data structure. Deletion means we need to delete some value from your data structure. Display means what are the data values that we are having in your data structure. We need to display those all data values here. Okay, so these are the basic operations that you have to perform on your data structures. So if I want to perform these operations sequentially means here, so first I need to perform some insertion with one side and the deletion is with the other side here. So like that one sequential approach. Directly we are not going to a middle element, we are not directly going to the nth position element and we are not performing the operation. First we need to go with the 0th position element, we need to go with the 1st position element, next we need to go with the second position, third position, like that we need to move to the nth position here. Like that one sequential approach you have to follow in a linear data structure. Whereas in non-linear data structure, we are not following any sequence. That is, we may be directly going to the second position, or we are directly we can go to the 5th position, or directly you can go to the nth position, and you can perform your operation. Okay, like that your operations are takes place randomly. So that type of data structures are called as a non-linear data structure. So the compound data structure means nothing but if a data structure is takes more than one data value, then those are said to be the compound data structure. And based on the way of performing your operations, they are categorized into the again two types. That is a linear data structures and a non-linear data structures here. Okay, so this example for linear data structures, stack and queue, and those are the things we have to discuss in our further chapters here. And similarly, non-linear data structure. So in our further classes, we will discuss about in detail about the each and every data structure and their implementation and programs for that. So we'll discuss about that. Okay. So before we are going to those things, so first I need to understand the concept. So that is called as what is mean by data type and what is mean by abstract data type. So this is the concept we are having abstract data type. While you are working with this data structure, we hear one term that is called as a abstract data type. So before I'm going to abstract data type, so what is meant by data type? So data type means nothing but it is a collection of your data values and a set of operations on those data values. So simply the data means that maybe sometimes you may be consider those are as a objects. So either objects or data and operations. So simply the data type is nothing but the collection of either data values or objects and set of operations on those particular data values. So that is said to be the data type. Whereas abstract data type means the abstract data type is also you observe it is nearly it is a data type. It is a data type that is organized in a such a way that the specification of the object or data values and operations on those data values are separated from the representation of the objects and the implementation of the operation. So what does it means? Okay, so if you observe, both will be the definition nearly both will be the same, but there is a small difference we are having between the data type and abstract data type. So what is that difference? So we are having between these two means so just to you observe the difference between the what is meant by data type. Just I'm giving the one example. With that example, you can understand the what is meant by data type and what is meant by abstract data type here. Okay. So let us take first. I need to take the data type. So this side data type I am consider, and the other end we need to consider the abstract data type. The other end we need to consider abstract data type. So data type means, suppose if I declare one variable like this int a. Int a, if I am declaring the one variable like this int a, what does it means? Means the a is a type of variable. A is a type of variable. What type of variable it is? It is an integer type variable. It is an integer type variable, and on this particular variable you can perform some operations. You can perform some operations here. What type of operations I can perform? So I can perform some arithmetic operations like addition, subtraction, multiplication, divisions, or I can perform some increment and decrement operation, or some logical operations, or some relational operations. So like that I can perform. So what is the definition of data type? Data type is nothing but it is a collection of data values, either collection of objects or data values. So what is the definition of your data type? A data type is a collection of data values or objects and set of operations that are performed on those particular objects or data values here. So the meaning here is that A is a one type of variable. What type of variable it is? Integer type variable. So which is capable for taking some integer values, and we are performing the some operations on those particular values. So means for example, if I'm taking the A, so A is equal to, I can take the 20. And after that, I can change the A value as A is equal to A plus 3. What does it means? A value is previously 20, 20 plus 3, that is 23. A becomes, means we are performing some addition operation in, or similarly you can perform some subtraction, and if I may perform some multiplication, like that different type of operations I can be performed. And these kind of operations, so addition or subtraction, multiplication, for these operations, who are giving the implementation? Means a system. So integer is one type of data variable, and for this integer data type, so we need to take the some integral values, and these integral values, whatever we are considered for that particular variables, on that particular variables we can perform the some various operations. And these operations are defined by whom? System. So system is defined all these things. So just what we have to do, just we need to declare that a variable of that type, and we are working with that particular type only here. And after that, whatever operations that are given by the system, only those operations I can perform. For example, if I take the variable like this, A is equal to A plus, if I take X, A plus X, if I specify like this, is it possible? No. Why it is not possible? Because of X is a character type and A is a integer type. We cannot add these two. How my system is defined? The system can be defined as, I can take the integral value, and this on this integral value we can perform the operations of type integral type only. So addition of integer type, subtraction of integral type, multiplication of type integer type. So like that they are defined. So we cannot perform this kind of operation here. So these particular operations are defined by whom? System. So system is given some operation for us. So just we have to work with that operations. So we don't know about how that operations are implemented. What is the definition of that particular operation? We don't know about that. Just what we know, just how to use it. How they are performing, we don't know. How to use it, those operations, we know here only here. Okay. So that concept is called as a data type. So data type is nothing but simply the system itself is defining the some group of values, and on that collection of data values, some operations they are defined. Just we have to work with that particular only. So that is called as a data type. Now coming to abstract data type. Suppose if I'm taking the abstract data type, so in this abstract data type, for example, if I declare one abstract data type like, let us take a list. For example, I am taking the list. A list means what is meant by list? Simply, list is nothing but a. So let us take how my list is look like. So like that, I have to take the list. So let us take this 1, 2, 3. So this is a 0th position. Let us take. This is 1th position. Let us take. I'm taking here. This is 1th position. This is 2nd position, and this is 3rd position. This is 4th position and 5th position. Okay. So in these positions, appropriate data values I may be considered. Let us take in this position, I need to take the some 34, and in this position value I need to 45, and in this position I need to take some 67 value, and in this position I can take the 55 value, and in this position I need to take 7, and in this position I need to take the 43 value. Okay. So basically these are the operations. Okay, suppose I don't have these data values, for example. Only operations are there. So now in this list, what is the basic things I require? So the basic thing is required is the size. What is the size of my this particular list? What is the size? So size is here is 6, 0 to 5 positions means a total. My list is capable for taking the 6 data values. It takes the 6 data values. Now the second thing is we need to perform with this is what type of operations I can be performed on it. What type of operations I can be performed on it. So what type of operation I can perform? So the one operation is I can insert one data value. So where I can insert? In 0th position I can insert, or in 1st position I can insert, or in 2th position I can insert, 3rd position, 4th position, or 5th position, in any order. Maybe 5th position directly you can insert. Suppose if I want to insert one data value into 4th position, what I have to do? Simply I can take the A of 4th position is equal to, simply I can take 45. Then what is the meaning of this one? Simply the meaning of this one is in this particular position 45 is inserted. Suppose if I take A of, let us take A of 2 is equal to, let us take I'm taking the 25. What is the meaning of this one? So in the A of 2nd position 25 is inserted. Okay, like that one operation that you have to perform is insert operation. We need to perform the one insert operation. Next we can perform the delete operation. So delete means so we need to remove the some element from the appropriate position. For example, in 20th 2nd position I have the 25. I want to remove it. So if I want to remove it, what is the meaning of that one? Means simply in A of 2nd position, in 2nd position, so what I have to do? Simply I need to place the 0. Then what happened? So this particular 25 is removed, and in this position 0 is inserted. That means it is deleted from this list. So that is one kind of operation I can perform. And the another operation that you have to perform is display. So display means whatever the elements are there from 0th to 5th position, just I want to display that. So in 0th position, what element is there? So in 0th position, what element is there? So nothing is there. So first display, what it display? It nothing it displayed in 0th position. Okay. In 1st position, nothing is there. So first nothing is displayed. Next nothing is displayed. Next nothing is displayed. And next 0 is displayed. Next nothing. Next 45 is displayed. Next nothing. So like that I can display the data values. Okay. So this list is a what? It is a collection of data values, and collection of data values. How many data values? I can take 6 data values into this list, and on this list how many operations I can perform? What are the operations I can perform? The operations are insert, delete, and display. Okay, so this one, so that is list is a one kind of, so with this particular list I need to, what I have to do? I need to define one data type for it. So we need to define one data type. What is the data type? My data type name is list. And what is the things that we have to define for this list means my list is capable for taking the 6 data values, and on that list I need to perform these operations. I need to perform these operations. So with these things I need to define one data type. I need to define one data type. Okay, then that data type is called as a list data type. So list data type. Okay, so here I need to take a list. The list is taking the some set of data values, and on that list I need to perform, these are the set of operations I need to perform. So with these things I need to define one data type. That data type is called as a list data type. And in this list data type, so what type of operations we have to perform? Insert, delete, and display. And what data values it will be takes means the 6 data values it will be takes here. Like that, I need to define one data type. So now it is called as a list data type. But my term will abstract. So I know what is data type. So list data type means that it is a primary data type. Already this list kind of data type is existed in my system. No. So what I have to do? I need to create a new data type name, that is list, and that list is capable for taking the 6 data values, and on that particular operations I need to perform these operations, whatever the operation I have to specify here. That is insert and delete and display. These are the basic operations. We have so many other operations here. So now what is meant by abstract means here? This insert operation or this delete operation. So this insert operation and this delete operation and this display operations may have the implementation part or may not have the implementation part. Means here, so implementation means for example, if I'm taking this data type, int a is equal to 20, and then a we can perform the addition operation. So whenever I'm performing this operation, when I'm performing that addition operation, means here, if that addition is already defined, how this addition is performed, then only I can use it. If they are not defined, I cannot use it. Okay, so in this case, data type, your all operations are predefined, they are already defined. Just what I have to do, I need to use it. But whereas coming to my abstract data type, here also I need to create a one data type, that is user defined data type, that is user defined data type, and this user defined data type is having the some set of operations, and these operations may have the implementation part or may not have the implementation part. Means here, how I am performing these things. Maybe I am specifying that things, or may not be I am specifying that thing here. So if I am specifying that, then my users may be using that one. If I am not specifying the implementation part, then what I have to do? Simply the user is taking the insert operation and they are performing the insert operation. They are giving their own definition, how they are performing. So in my sense, how I am performing insertion, suppose I am taking this list. So in my sense, insertion, first 0 position I want to insert, next 1th position I want to insert, next 2 position I want to insert, next 3rd position I want to do. In that sense, I am giving the definition for insertion. For suppose if some X person is there, suppose if that X person wants to give the definition for insertion like that, instead of starting with 0, if they want, so insert the element into 5th position, next insert the element into 4th position, next insert the element into 3rd position, and insert the element into 2nd position, and insert the element into 1st position, or insert into the some position element into 0th position. Like that they can be defined. But suppose if I have some Z person, so that Z person may be giving the definition for insertion is like, they can insert the element first in 2nd position, after that 1st position, and after that 0th position, and after that goes for 3rd position, next 4th position, next 5th position. Like that he can define the insert operation. That means that there is no fixed implementation for the insertion. So I'm not fixing the implementation thing, that is insert. So if I'm specifying the insert means, so we need to perform insert in this way only, like that I'm not fixing. So it may be changed later. Similarly, delete. I may be deleting in any position. In my sense, I can delete in from first position onwards. Maybe in your sense, you may be deleting last number onwards. Or some in other point of view, that person may be deleted in the randomly. They may be picking the and they may be deleting the element. Okay. So like that, this particular definition for my data type is not fixed. Not fixed here. Okay, so that's why it is called as a abstraction. Abstraction means here the insert, delete, and display, whatever the operation that you have to specify for your data type. So they may be hide for the your users. So if I'm giving one implementation, that implementation may be used by that person or may not be using that person. Then what he will be do? Simply he will be giving their own definition for that operation. So what I have to do, simply I need to give only I need to give a set of data. Means, what is the size of my this list, or how many data values it will be take this thing, and what are the basic operations that you have to do. Need to perform on that. With these things, I need to create a data type, and this data type later, whatever the operation that I have to define, that may be changed by the your end users or changed by the others. Whereas in this data type, suppose if I'm declaring this a plus 3, it is not changed. They are already defined. We cannot change the meaning of that one. But here, I can change the meaning of that one. So that's why it is called as an abstract data type. So in the name itself, abstract. Abstract means here, just we need to give the overview. Need to give the overview. So this is the my data type, and this data type is taking these many values, and on this I need to perform these operations. And how these operations I have to perform, I am not specified that. So that may be whenever the people wants to use, and they may be give the implementation for that particular thing here. So that is called as abstract data type here. So that is the definition between the that is the difference between the data type and abstract data type here. Okay, so data type. So in other sense, we simply remember that data type is nothing but your primary data types. That is int, float, character, and double. These are all the primary data type. And in this, they are giving the some data types for us, and they are defining the some operations. Just I have to use that operations only. But whereas abstract data type means that it is a user-defined data type. So user how to define this data type, and in this data type, whatever the operations that are defined by user, that may be changed later. Maybe using the same operations, or maybe changing that operation, and maybe performing that operation. So operations are fixed, but the way of performing that operations are changed by the my user's point of view. Okay, so that's why it is called as a abstract. It means that just we are giving the overview about the particular data type here. So that's why it is called as an abstract. So data type. So that is the major difference between data type and abstract data type. Okay, if you observe the definition, both will be the same, but in the name itself is there is here. Just you observe here, that is separated from the representation of the objects and implementation of the operations. So the implementation of your operation may be changed. They are separating what the data values they may be taken and what operation they may be performed here. Like that, I'm separating this thing. Later on, whatever the operation required by user, those operations may be changed according to that, the person may be defining their operations here. Okay. So that is the major difference between your data type and abstract data type. Okay. So for my data structures, whatever the data structures that I have to discuss later, linear data structures and non-linear data structures, these are all user-defined data structures. So as per my requirement, I want to create the data structure. So that's why in this concept, I need to use the abstract data type. So ADT, that is called as ADT. So ADT means abstract data type, and what it specified means it is specifying the data type of how your data is organized and what are the operations that you have to perform on that particular data values here. So we have to separate those things and we need to work with that here. Okay. And the best example I'm taking here is list data type. So I need to create one list here, and on this list how many data values I want to take, like that I have to define, and what are the operations I need to perform, like that I need to separate here. So these operations, if they want to perform here, they maybe give their own implementation. So how they performing as their requirement here, they may be giving the implementation for that particular data type. Okay. So this is the major difference between your abstract data type and a data type. Okay. Okay, and the next thing. So I think you all of you clear about the abstract data type and data type. Okay. So an abstract data type sometimes abbreviated as a ADT, and it is the logical description of how we are viewing the data and the operations that are allowed. So without we are going to the implementation. So what are the operations you have to perform and how your data will be there here. But the implementation details may be later we have to implement it. Okay. Simply an abstract data type is nothing but it is a mathematical model. So it is simply a mathematical model for our data type. So we have this kind of data values, and on this kind of data values I may be performing this type of operations, like that I have to specify. So simply I'm specifying the behavior about your particular data values here. Okay. So this is the example I'm discussed here. So I have the one list, I need to create the list, and the list size is 7. And what type of operations you have to perform on this means addition, whether the adding of element or inserting of element, removing of element or deleting of element, searching for a key, and getting the index. So particular position, I have the one element, so I want to get the index of that element. And I want to insert the element into a particular position, or I want to reverse the element, or I want to sorting the elements on that. So like that, these are the various operations that I have to define. So these operations may be later based on the requirement of your user, he will be performing the operations. Or they may be giving their own implementation for that operation. Okay. So this is the abstract data type. So abstract data type is nothing but it is a mathematical model which will be defined for your data types. So which will be taking the some set of data values and the various operations that you have to specify on that particular data values. And these operations may be implemented having the implementation details or may not have the implementation details. But whereas data type means it is a primary data type, and it is also having the set of data values and operation on those data values. But these things are fixed. We cannot change the definition of that particular operations. Whatever the operation they are defined by the system, you have to use those operations as it is. Okay. So that is the terms of data type and abstract data type. Okay. So now we need to go to the new term, algorithm. You already hear this term into your programming for problem solving. So algorithm is nothing but it is a finite number of instructions, finite set of instructions which is used for to perform a particular operation here. Okay. Algorithm is nothing but it is a set of instructions to perform a particular job or to perform a particular task. So I have the one problem. So to solve that problem, so what are the steps I have to follow? That number of steps is nothing but a algorithm. Okay. This word algorithm is comes from the Arabic word algorithm. So what is this algorithm means? This term comes from the name of your Arabic mathematician, that is AI covers me. So this is the person. So this person's name initially having the AI. So with this particular thing, this term algorithm comes, and later on this algorithms becomes the algorithm. Okay. So this algorithm means nothing but simply it is a solution steps. These are nothing but the solution steps for a given problem here. For example, my problem is adding of two numbers. This is my problem. How I'm performing the adding of two numbers means I need two numbers. After taking these two numbers, then I need to perform some addition operation on it. Okay. So for this, what I have to do, what are the steps I need to follow? My steps are, initially I need to read the one number x. I need to read the one number x. Next, read the second number. Next, I need to read the second number. Next, after that, what I need to perform the addition between those two numbers. That is x plus y. Initially, read the x value, read the y value, and then add the x plus y. And finally, you are getting the results, and you can display it here. Okay. This solution steps, this group of solution steps is nothing but a algorithm. So algorithm is nothing but it is a sequence of steps. Sequence of steps to perform a particular job. What is my job? Adding up two numbers. So to accomplish that particular thing, what are the solution steps I have to follow? So that particular thing is called as an algorithm. Okay. So in order to represent your algorithm, what is the structure I have to follow? Means majorly your algorithm containing these following steps. First, input step. So input step means what input values I need to give into my algorithm. Means for example, if I'm taking the addition of two numbers, what is the input values I need to give? X and y. Read x, read y. So these are called as input steps. These are called as input steps I need to specify. Next, what I have to do? Next steps, assignment steps. Suppose if I want to take some initial values like x is equal to 20, or x is equal to 30, or x is equal to 40, or either result addition of two numbers is equal to a, some c is equal to a plus b. So a and b are added and assigned to c. That steps are called as assignment steps. Next, sometimes you may be having the decision steps. Decision steps means if decision step means that if else, whatever the things that you have to use it for if else. That is, if condition is true, what I have to do? If condition is false, what I have to do? So if else, that decision things I need to specify. Repetitive step means some steps you may want to repeatedly executed several times. Looping. That looping steps you need to specify. And finally, output steps. Okay. If you take any algorithm, this algorithm may be having these key steps. So based on the requirement, based on your requirement, sometimes steps may be having and sometimes may not having the some steps here. For example, if I'm taking the addition of two numbers, in that addition of two numbers, I have the input step because of read x, read y. Suppose if I have the assignment step in this particular thing, what is that assignment step? C is equal to x plus y. So that assignment step is there. And in this, there is no decision step. So we are not having the alternative steps here. So that's why decision step is not there. And we need not to repeatedly executing the particular steps several times. So repetitive step is not there. Next, output step. Output step is there. That is print the result. So print the C value. Output step is there. Okay. Like that, if you want to write any algorithm for a particular problem, so that algorithm may having these particular things. So you need to follow this structure here. Okay. So next, what are the properties of an algorithm? So if you want to develop any algorithm, your algorithm should be having some steps, some properties or some characteristics. What is that things means? First input and output. So your algorithm should be taking at least some input and produce some output. Without taking the input and without producing the output, what it will be performed? So it is useless. So that's why your algorithm should be taking some input and should be producing some output. And after that, finiteness. So next one, so next thing is finiteness. So finiteness means after finite number of steps, your algorithm must should be terminated. That means if you are taking the addition of two numbers, we are reading the x, we are reading the y, next performing the addition, that is c is equal to x plus y, and print the c. After that, my algorithm is terminated. It must and should be stopped. Suppose if I'm not having the ending point, then what output I'm expecting from that? Infinite output I'm expecting from that. So if your algorithm is providing the infinite output, means it is a not good algorithm. So that's why after finite number of steps, your algorithm must and should be having the ending state. Means once your task is accomplished, your algorithm must and should be terminated. Okay. Next to definiteness. So definiteness means in your algorithm, whatever the steps that you have to written, these steps must and should be clearly understandable. Clearly understandable. Don't create any confusion for my end users, because of you may using your natural language statements for writing the algorithm. So if I confusing that steps, or if I'm confusingly specifying the steps here, while the other peoples they wants to write the program for this algorithm, they may be confused and they may be giving the wrong results for it or wrong implementation for that algorithm. So that's why. So if I specify my steps clearly, then my implementers may be clearly understand my steps and they may be clearly implementing my algorithms. Okay, so that's why your algorithm steps must should be clear. Clearly, we need to define. Next one, effectiveness. Effectiveness means your algorithm must should be effectively providing your output, even though if I'm using the manual approach. So if I'm using the pen and paper, so if I'm taking the roughly, suppose addition of two numbers, for this I'm taking the, so read x, next read y, next c is equal to x plus y, next print c. Like that I'm taking my algorithm. Suppose if I'm using the pen and paper, read x. So suppose if I'm taking the read x, so what I have to do? So simply x is equal to 20, I need to take, and y is equal to, so I need to take 30. Okay. Now what I have to do? C is equal to, so x plus y means 20 plus 30. That is equal to 50. So I'm getting the 50. So print C means print the result means simply display the 50 as a result. So it is calculating my results correctly? Yes. So then my algorithm is effectively calculating my results. Okay. So like that, your algorithm is taking some input and output. So input X, input Y I am taking. Finiteness. So after calculating this, my algorithm having the ending state. Have the ending state at your algorithm. Okay. Definiteness means X. Clearly X is equal to 20 I want to take, Y is equal to this value I want to take, and after that C is equal to I need to perform this operation, and next display this result. Like that I clearly define my steps. Effectiveness. So if I'm taking some sample input, I'm testing this, then it gives a correct result or not. So correctly it gives a result. So that is effectiveness. So like that, if you want to write solution steps for any problem, solution steps means that it is an algorithm. If you want to write the algorithm for any kind of problem, your algorithm must should be having these properties. Without these properties, if you write the algorithm, your algorithm is not a good algorithm. So compulsory you have to follow with these things, and you need to write your algorithm here. Okay. So that is called as properties of your algorithm. Okay. So next one. Now I'm writing the algorithm. After writing the algorithm, I need to analyze my algorithm. It's analysis. What I have to analyze means my algorithm is a effective algorithm or not. Suppose simply to give the correct result means it is an effective algorithm. No. What thing I want to analyze means while I'm implementing this one as a program. So if you convert into this one into a program means you may be converted into C or C++ or Java or any program. We are writing some solution steps for a problem. We take that solution steps and we can implement that one into program into any programming language. For example, if I'm taking the addition of two numbers, for that I'm writing the algorithm. Read x, read y, c is equal to x plus y, print c. These are my solution steps. Suppose I want to implement this one into any programming language, for example, C. Then what I have to do? I need to write first what I have to do, void main. Next, I need to declare the two variables int x, y and c. Next, printf enter x and y values, scanf percentile d, address of x, address of y. Like that I need to write. Next after that c is equal to x plus y. Next after that print percentile d c. Like that I am writing the program. So like that, if you want to take any algorithm, if I want to convert that algorithm into any programming language, now that program execution is taking the how much time and how much space in my computer. Suppose if my algorithm is taking the suppose addition of two numbers, for that algorithm, if I'm writing the C program, suppose if my C programming taking that for displaying the result 2 hours or 3 hours, for example, if I'm reading the x is equal to some 20 and y is equal to 20 and display the result. While it display the result, suppose if it takes the 2 hours time, means it is not a correct algorithm because of it takes the 2 hours time for to calculating the result. Okay, we require less time within the fraction of seconds. It must should be give the result. In such a way, I want to write my steps. Similarly, how much space it occupies while you are executing. So suppose if it occupying the more space means it takes the more time for execution. So that's why what I have to do, I need to take some less time and less space for executing my algorithms. So these are the things we are using for analyzing your performance of your algorithms. Okay. So to analyze your algorithms, so what I have to do? So we need to analyze your algorithm. So what you have to do? We need to take the how much time it required for execution and how much space it occupied while it executing. So these two things we have to use for estimating the performance of the algorithm what you are developing here. Okay. So that things are called as a time and space complexity. So time complexity means here nothing but what is meant by time complexity means that the time complexity is nothing but it is a amount of time. It is a amount of time required to run the program or run the your algorithm. Whereas space complexity means it is the amount of space needed to run the your program or run the your algorithm. So that is called as a time and space complexities. And how I can compute this time and space complexity for my algorithms or my programs. So how much time it takes, how I can estimate it, and how much space it occupies, how I can estimate here. So that thing I will discuss now. So I will discuss these things next class. So I think your time is already 10:25. Okay. So now we are going to the next thing, that is exam. Just you be ready for this exam. So just I will launch the poll and you answer for this.